What is going on, everyone? It's Javi here, and today I'm gonna explain to you how nor'easters form. So, a lot of people really don't know the origin of this, and I want to tell you guys how they form. It's not If you know the weather, it's not gonna be too difficult to know really how they form, since it's pretty easy stuff to know how they form. So, hold up, let me pull this up. All right. So what exactly is a nor'easter? So first, before we know how they form, we need to know what exactly is a nor'easter. And nor'easter is basically an area of low pressure along the east coast of the US that has a defining strong northeast wind. So usually when people think of nor'easters, they think of heavy rain or heavy snow, but those things aren't really necessary to be defined as a nor'easter. Really, the only thing that something needs to be defined as a nor'easter is basically a defining strong northeast wind that's right along the northeast coast of the United States. So it doesn't need really that heavy rain or heavy snow like most people would expect for a nor'easter. But most of the time, nor'easters usually bring either heavy rain or heavy snow, but not in all cases. They bring it. Sometimes it could be just a windy nor'easter without much rain or snow, but most of the time they bring heavy rain and heavy snow. And most nor'easters bring different impacts, and some are stronger than others. Some of the strongest ones could cause like billion-dollar disasters, which is insane that these nor'easters, even though they're not defined as hurricanes, sometimes they could be as powerful as hurricanes, which is like mind-blowing that stuff like this could happen in the winter. But it all takes like several different factors to create nor'easters that are just as powerful as hurricanes. Some could be even as powerful as major hurricanes at times. So let me give you some examples of powerful nor'easters. So the one example I could really give as like a super strong nor'easter that could be compared to major hurricane status kind of storms was the 1993 storm of the century that caused basically extensive damage from Texas to Canada, also affecting Cuba, and it just brought winds up to category 2 strength in some areas. We had, I think, 100-mile-per-hour wind gusts reported in Cuba and maybe in parts of Florida as well, where we had basically a huge squall line of thunderstorms and stuff, producing a lot of tornadoes at around the southeast area. Also, a lot of snow in some areas. We had up to 4 inches of snow in Florida and up to over a foot of snow around the Alabama area, which is insane to see that type of snow that far south. And in the Northeast, it brought just heavy snow, heavy wind, a lot of coastal flooding, and a surprising 208 people died by this storm that wasn't even considered a tropical cyclone, which is insane, and caused $2 billion in US dollars in damages, which is about 3.5 billion in 2017. And a more recent nor'easter I can name was the nor'easter of January of 2016, more known as Winter Storm Nemo, which was basically a huge blizzard that pummeled the northeast coast. We had over 30 inches of snow in New York City, which broke a record in New York City. We had almost 2 feet in Philadelphia, Washington D.C., and we had over 2 feet of snow around the Baltimore area, and it was just a widespread area of over 2 feet of snow, which was insane. Also, strong winds over hurricane force in some areas, and this was just like a crazy, crazy storm. And the next one, we had Superstorm Sandy, which is basically the most iconic of them all and the most devastating of them all, where basically an Arctic cold front that was winter-like mixed in with a tropical warm hurricane, and it just combined together to create basically this powerful superstorm that no one has really ever seen before, ever since we started recording weather stuff. And it killed over 200 people and caused $70 billion dollars in damages, which is now the third most costliest natural disaster in U.S. history. Was formerly second until Hurricane Harvey surpassed that. And now let's see, when do nor'easters usually happen? They usually happen between the months of September, April. That's when the water temperatures are like have a much bigger contrast in temperature than the air temperature. During the summer, the air temperature and the water temperature is mostly the same. So those nor'easters don't have that instability to really create those powerful nor'easters. But between the months of usually September through April, we have usually a much colder air temperature mixing in with the very warm Atlantic Ocean off thanks to the Gulf Stream that moves up and brings that like warm Gulf water up towards the northeast to create that instability to maintain these powerful nor'easters during those couple of months. They can happen in the summer, but it's a lot more rare to happen in the summer. And next, I'm gonna really show you a map representation of how they usually start. And let me open this up. Um, Wait a minute. All right. So, so here's where they usually start. So they start with a pre-existing area of low pressure. Usually comes from the southeast, since during those winter months, most of the air is rising towards the south since it's obviously much warmer. So they usually come from the southeast, move up north. Sometimes they may come from the northwest and from Canada with those Alberta Clippers, but I would say most of the time they come from the southeast and then mix with that Arctic air to create that instability to create those powerful nor'easters. And I also include this like very big detail here of very warm Gulf Stream water compared to the air temperature in the winter that is key to making these powerful nor'easters. And next I'm gonna show you the Next, I'm going to show you the next thing. So, as the low pressure starts to move up, we see the warm waters of the Gulf Stream basically like forcing that air to rise and making that air want to rise as fast as possible. And we see the water vapor rising very quickly. And thanks to usually the cold air that like goes by the northeast during the winter time, we see that cold air is known to have higher pressure, and the higher pressure tries to move towards a lower pressure, and as it does, it forces that warm air up and that warm water vapor up to create convection, and that creates the thunderstorms for the nor'easter to strengthen. And as that high pressure tries to move towards the lower pressure area, that's what creates a powerful wind of the nor'easter. And the cold air starts to like rotate like this, um, and the warm air tries to fill in the cold air, while the cold air tries to fill in the warm air. Basically, like a game of tag. The high pressure trying to tag the low pressure, but it never happens because we have that Gulf Stream like continuing to make the air pressure a lot lower since it's a lot warmer along the Gulf Stream. And then I'm gonna show you the next map, and you could see that the nor'easter just becomes powerful. We have that Arctic air filling in that low pressure, and that Arctic air tries to fill in the low pressure, creates a wind. The thunderstorms, thanks to a Coriolis effect, that are offshore move towards the northeast since low pressure areas move counterclockwise. So those thunderstorms move towards the Arctic air, and that creates more instability, and that increases the rain showers or snow showers in those areas to create those major blizzards. And that's what like creates those powerful nor'easters. And due to Sandy mixing in with an Arctic air that's a lot warmer than what most nor'easters typically are. That's what made Sandy so powerful. You had like winter-like cold from mixing in with basically a summer-like tropical hurricane, which just exploded in pressure, and it just forces that low pressure up that cold air, and then as it moves up north, that's when the nor'easter usually starts to weaken because it loses contact with that warm